All right, so let's take a look at this problem. It's the last problem on this assignment. Um, we have an equation. We know it's a conic section. The biggest exponent is a 2. We know that since only one variable is being squared, that the conic is a parabola. Since y is being squared, the graph of this parabola will either open to the left or open to the right, depending upon the value of p. So we need to rewrite this in standard form. Uh, the first thing that I notice about this equation, all of the numbers are an even number, so we can divide everything by 2. Let's do that. If we come in and divide each term by 2, and of course 0 divided by 2 is 0. So we've got x minus 2y squared plus 8y. No, not plus 8y. And not 2y squared. All right, I forgot to divide by 2. Minus y squared plus 4y plus 2 equals 0. So I'm sure that people were yelling at the screen telling me to divide by 2. All right, so let's get the y's on one side of the equation, everything else on the other. Um, I'm going to keep the x plus 2 here. If I move the y squared to the right-hand side, that negative y squared will change sign. If I move the 4y to the other side, if I subtract 4y from each side, I like to write the squared term on the left-hand side. I'm going to leave myself a little bit of room so I can complete the square. Half of negative 4 is negative 2, but when I square that negative 2, I get a positive 4. That adding that amount makes that left-hand side a perfect square, and we can factor this to y minus 2 quantity squared. Since I added 4 to the left-hand side, to balance the equation, I'm going to add 4 to the right-hand side, and I get x plus 6. Now, I'm going to put parentheses around this and put a 1 there, just to emphasize how to find the value of p. But first, my vertex has coordinates of negative 6, comma positive 2. I take 4p and set it equal to that coefficient. So this p is equal to 1/4, and I'm going to look at that as 0.25. All right, so with y that's being squared, I know that it opens to the left or to the right. Since p is positive, I know that this parabola opens to the right. And there's two lines that we're interested in. One is, we refer to it as the axis of symmetry. It passes through my vertex. My drawing is not very good. It passes through my vertex. The other line is perpendicular to this line. It's called the directrix. My parabola never intersects my directrix. The parabola will always open away from the directrix, and inside the bowl of this parabola will be a point that is the focus. My sketch isn't very to scale because the point of intersection of these two lines, the distance from this point to the vertex, should be the same distance as from the vertex to the focus. And you can see that in my picture, it's not anywhere near the same distance. But this is just a sketch, and it's just helping us to get the coordinates and the exact information. So if I'm if I'm at this vertex, if I'm moving to the right and to the left, that's changing the x coordinate. So if the coordinates of this vertex is negative 6, comma 2, if I move to the left 0.25, Then I'm subtracting 0.25 away from negative 6, so I get negative 6.25. That's the equation for the directrix, for the line that's the directrix. If I add 0.25, I'll be at negative 5.75, comma 2. There's my equation. There's the coordinates for my focus, and the horizontal line here is y equals, well, you can see both of those have a y coordinate of 2. So there's the 5 things that we wanted, including we rewrote the equation in standard form so that we were able to identify the coordinates of the vertex. We used the coefficient in front of the linear term to find the value of p. The sign of p told us that the parabola opened to the right, and it also gave us the magnitude, the distance, to, if we move to the right, to find the coordinates of the vertex. If we move to the left, to find the equation for the directrix. So with the 2 lines, the 2 points, and the value of p, we found all 5 things. So I hope that helps, and I'll talk to you later.